zero exponent rule, which I am first going to explain where it comes from so that it makes sense. Okay, so we always say anything to the power of 0 equals 1. But have you ever wondered where that comes from and why it works? This is why. I don't like the fact that they used so many 4s, so I'm going to make my own example on the side here. If I have 3 to the power of 4 divided by 3 to the power of 4. Now, the rule says to us, the second law of exponents, which is the division law, it says to us, what are we going to do with these exponents? What does this, it say we're going to do with the exponents because we are dividing? It says we will. Is anybody there? There we go. Thank you, Entle. We will subtract them. So it's going to be 4 minus 4, which is going to give us a 0. And the law says this will be equal to 1. Now, the reason that's true is because if I say 3 to the power of 4, that means 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3. What is the common factor between 3 and 3? What is my common factor between 3 and 3? It's 3. How many times does it go into itself? Once. So let's start with the first ones. Once and once. Second one. Third one. And last one. Okay, so then we're left with 1 times 1 times 1 times 1, which is how much? 1 times 1 times 1 times 1 is 1 over 1. And what is 1 divided by 1? 1. Okay, so do you see where this law comes from? Almost all the laws, you can refer back to law number 1 and law number 2, and you would be able to prove them. So that is where the rule comes from. This is not a law, it's a rule, okay? Hence it says the rule explained. Now, let's get going with these, okay? I have a lot of exciting stuff for us to do today. So I want us to get going with this. Number 1, what is my answer? 1. N to the power of 0 is just 1. Number 2, what is my answer? 1. Okay, we're on a roll, I see. Number 3, what's going on there? Is the answer 1 for number 3? Equals. No, it's 5 because only the y has the exponent of 0, right? So this will be 5 times 1, which is 5. Number 4. Fastest fingers first. We should actually play that game where you guys give me answers and we see who's the fastest, okay? Number 4 is number 8. It's negative 8, excuse me, times 1, which will give you negative 8. That is true. Number 5 is 1 because the whole bracket is contained inside the power. So it's a plus b, whatever a plus b is, all raised to the power of 0. So my answer is 1. Number 6, 1 plus 1, which is 2. Beautiful. So a to the power of 0 is 1 plus b to the power of 0, which is 1. And my final answer will be 2. Number 7, 3y. Oh, you guys are on fire. This is 3 times 1 times y. And this will just give us 3y. Number 8. Number 8 is 10 times 1, which is 10. Number 9. A, B, C. Leachilo is waiting with my answers. So this whole bracket will be equal to 1 times A, B, C. And this will give me A, B, C. Number 10, 1. Because everything is to the power of 0. Number 11. I can't catch you guys with anything. That negative is outside, so it's not part of the power of 0. So it will be negative 1. Number 12. Okay, let's do number 12 together. First part of number 12 is what? The red part is 2. Plus, second part is 1. Plus, third part is A. Okay, now I have 2 plus 1 plus A. How much is that? Oh, I did catch you out. What does 3A mean? Means 3 times A. Are we timesing 3 with A in this case? Look carefully. Are we timesing 3 with A? Nice. You must be careful. This is 3 plus A, which is not the same as 3A. Okay. Let's go to number 13. First part is how much? 1 minus second part, 9 minus third part, 1. What's 1 minus 9 minus 1? Nope, count carefully. Don't rush, it's not pluses, remember. 1 minus 9 minus 1. Nice, because 1 minus 9 is how much? -8, and then you minus another 1, so that is -9. Okay, let's go to number 14. M plus 2 all in the bracket. That gives you what? To the power of 0. This is 1 minus what? Minus 1 minus. My last part is what for the sum? 2. Okay, again, 1 minus 1 minus 2. My answer is. Ooh, I have a lot of answers here. What's 1 minus 1, guys? It's 0. Minus 2. The answer is -2. Beautiful. Okay, thumbs up, thumbs down. Do we understand the concept of these zero exponents, excuse me. Do we understand the concept of zero exponents before we start getting more interesting stuff? Okay, beautiful. Okay, now. Now, this is number 15. This has a couple of concepts that we have already done, so let's get going. Is there anything inside the brackets that I can simplify? Inside my brackets. Inside. It's all right, Jason, welcome. What can I simplify inside the brackets, guys? There isn't, right? There isn't anything we can do inside the brackets. XY squared is just XY squared. There's nothing much we can do. Excuse me. So we've checked brackets. Now we have exponents. Is there anything exponents-wise that I can do with the sum? Exponents-wise, yes, there is. What can we do? Let's start in the numerator. What am I going to do with my 2 over here? Magic word. Not times. Before you times, you first. No. Distribute. Thank you, Tali. We distribute, guys. This was the previous lesson. So you distribute over there and over here. And we're going to do the same with this 3 over there and over there. Okay. So it's going to be x to the power of what? To the power of 2. Thank you, Sanyani. Remember, we're multiplying, not adding. So it's not 1 plus 2. It's 1 times 2. So it's going to be x squared and y to the power of 4 times x to the power of 3, y to the power of 3 times, what's x to the power of 0? Times 1. We're done in my numerator. Okay, bracket number 1, is there anything that we can do there? No. So I'm just going to rewrite x squared y. Bracket number 2, xy cubed all to the power of 0 is equal to 1. Whew. Okay, let us go back to my numerator. What's happening there by my numerator? I am multiplying, so what can I do with my exponents? In the numerator, I can add them, okay? Remember, we're not plussing, like terms for addition and subtraction, but I can add my exponents. So I'll say x to the power of 5, y to the power of 4 plus 3 is 7. Right. We go to the bottom. I still have x squared y. Is there anything else that we can do with the sum? Yes, Ompa, tell us what you did. What can we still do with the sum, Kali? Subtract exponents. We're dividing. Beautiful people. Check here. Remember, law number 2 said if you are dividing powers of the same base, you can subtract the exponents. So this will be equal to x to the power of 5 minus 2 and y to the power of 7 minus 1. So final answer is x to the power of 5 minus 2, which is 3, and y to the power of 6. Nice. Remember to take your time, guys. We're making silly mistakes. This could happen in a test as well. So you must take your time. Make sure you're adding correctly. Make sure you're applying the correct rule. You're subtracting correctly, and so on. And you're following BODMAS. Do not forget that. Okay, screenshotters, I believe we are done. Okay. Now, we're going to start with combination questions, which just means we're going to do what we just did here. Okay, we take a bunch of the laws or the rules that we have learned so far. We're going to put them together in combination questions. So this was number 15. Let's go with number 16. Okay, brackets. Are there any brackets? No, right? Is there anything we can do exponent-wise to simplify this question? Because after brackets and BODMAS is exponents. Yes, Cali, what can we do? We can add. But that would be multiplying, guys. I mean exponents that we can multiply. Before we multiply, exponents that we can simplify. Before we multiply my bases and do all of that. No, you can't distribute where there is no brackets. Let me see if anyone catches what we are supposed to do first here. Exponents. Like terms. No, there are no like terms here. We're not adding. Guys. 2 to the power of 3 and 3 to the power of 2. Can we not simplify those? It is not 2 times 3. It's not 2 times 3, guys. You're not allowed to multiply before you do exponents. What we are doing now is doing multiplication before exponents, and that is not allowed. Okay? You first simplify exponents. All right, so let's simplify exponents. So what is 2 cubed? It is 8. And 3 squared? It is 9. So remember, if you first multiply 2 times 3, your answer is already wrong. Okay, you're already wrong because you're going to get a 6. And then what are you going to do with those exponents? You don't know what to do with them. Right. So we've simplified the numbers. Now we are multiplying. So we do what to the exponents? Do you see we did exponents before we did multiplication? Remember not to rush, guys. I know we know our rules, but we need to be careful. Let's start with the numbers. 8 times 9 is 72. A to the power of 8 to the power of. Okay, 2 people said 4, so I'm not sure. Okay, I'm going to write it out. It's to the power of 3 plus -2. And then b to the power of 4 plus 2 equals 72. And a to the power of what? This plus minus situation does what? Gives you a negative. So it's just a and b to the power of 6. Okay, I hope we have pen and paper writing this down. Some of my answers makes me feel we're not writing anything down. We're just sending answers to the chat. Okay, you must first work it out. Do not rush to answer. Write down all your steps. If you rush now, you're going to rush in a test paper. And it's going to be sad if you don't get the marks you deserve because you guys clearly know the work really well. Okay. Now, let's move on. Is there anything inside the bracket? Listen, inside the brackets that we can do anything about here? No. Okay. A squared b, we can't do anything about that. And ab cubed, we can't do anything about that. So brackets are out. Is there anything exponent-wise that we can do here? This was 16, number 17. Yes. What can we do with my exponents? Add. No, that's not where we start. We distribute. We're going to distribute. Okay. Remember, you cannot times this base with this base when there's still an exponent sitting outside. Okay, this exponent and this one first have to be resolved before you divide and multiply. Bad maths, guys. You can't throw out the most important rule in math. Exponent is way before division and multiplication. Okay, let's distribute. If I distribute my 3, then it's going to be a to the power of, oh, Sengyani already told me, 6 and b to the power of 3 times. Okay, I'm going to rewrite my numerator because I can't do anything about it. Over at the bottom, it's going to be a to the power of negative a, not b. A to the power of, Leachel is like light bulb moment, ding, 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 ding. I love it. Negative 1 and b to the power of negative 3. Okay, we've done exponents. Now let's move on to division, which means we are working over here. Step by step. Don't skip steps, okay? A6, B3 times. If we are dividing, what do we do with my exponents? Subtract. So it's going to be a to the power of 4 minus negative 1. And b to the power of 1 minus negative 3. Okay. So this will be equal to a to the power of 6, b3. This minus minus is going to cause what? We're working too fast ahead, guys. Keep up with us, please. Minus minus are going to make pluses. Pluses, okay? So it's going to be times a to the power of 5 and b to the power of 4. Now we are multiplying. So what do we do with my exponents? We add, okay. So it'll be a to the power of 6 plus 5 and b to the power of 3 plus 4. So my final answer is a to the power of 11 and b to the power of 7. Nice. We must keep going with each other, guys, okay? Don't go too far ahead because then the chat is full of what looks like random stuff. Because you see a 5 and a plus and a 2 and an 11 and a distribute and a multiply. And so it's just answers scattered everywhere and you're not sure what's going on. So let's go step by step together. If you already worked ahead and you have the answer, then check. Okay, don't try to quickly put all 5 steps in the chat because, yeah, we get confused. Okay, screenshotters, I believe we are done doing our thing together as a class. I like that. Leachile, that sounds like something your teacher says. Together as a class, let's go. I love it. Always, now I'm going to steal it. I actually like it. I'm going to steal it from now on. Okay, let's see what's happening here, guys. Any suggestions? Tandy is like, ish. Any suggestions? Okay, there is someone watching this lesson who is not connected to sound, so I'm worried that he can't hear anything. It's all right. Welcome, welcome. It's okay if you're late, guys. We do record these sessions, okay, these lessons, and you can access the recordings in our YouTube channel. So if you are late or you feel like you missed a big chunk of the class, just do that. It's just better to be in class so that you can interact. Yes, you can, Tali. We can tip and times. You are welcome. You can tip in times. Let's start with tipping in times. And I saw someone said simplify, but let's just first tip in times and then Senyani, we simplify. Okay. So this is number 18. You guys, in 20 minutes, you've done 18 questions. Jeez. Okay. So I'm going to keep the same one the same. The first one, the same one the same. Yo. Over 9m to the negative 3n squared. My divide is going to turn into a what? My divide will turn into a, thank you, Leachile, multiply. And then I have to tip the second fraction. So therefore, 3m to the power of 4n over 16m cubed in negative 1 has tipped. Oh, thanks, Tlali. That's so cute. Okay, now we've tipped 10 times. Somebody who said simplify, what exactly can we do here? Are we cross multiplying? We're not cross multiplying, but we can cross. The word multiplying is not the right one. We can cross cancel. Cancel is the word I'm looking for. So if you look at 8 and 16, do they have a common factor? Yes, they do. What is the common factor? 8. It goes into itself once and into 16 twice. 3 and 9. Do we have a common factor? 3 goes into itself once and into 9 3 times. Okay, we have cross cancelled. Now, do we want to first simplify the fractions? So do we want to first divide or do we first want to multiply? Let's take a vote. Divide, multiply. What do we first? Okay, Sanyani says divide. Rowa. Everyone else is not voting, so I'm going to end up going with divide. Okay, it seems like we're going with divide first. Sorry, Ompa. The votes have gone to divide. Okay, that means 1/3. Can we do anything about 1/3? Sanyani, remember, multiplication and division doesn't matter the order. Okay, it's the same as addition and subtraction. So whether you divide or you multiply first will not affect the order. So no, thank you guys. No, we cannot do anything about the numbers. So I'm going to keep them as 1/3. And then we are dividing. So what do we do with my exponents? What do we do with the exponents? We minus, okay? So it's going to be m to the power of 2 minus -3 and n to the power of 1 minus 2. This is all still over 3. Remember that 3 that was at the bottom there? Times. Let's work with this divide, okay? We're minusing our exponents still. So it's going to be m to the power of 4 minus 3 and n to the power of 1 minus -1. And this is all over 2. Okay, these minuses, what's going to happen? We have 2 of them. Negative, negative here, negative, negative over there. What do those become? Positive. Okay, so then I will have m to the power of 5, n to the power of n. Let's check carefully. What's 1 minus 2, guys? Not 2 minus 1, 1 minus 2. It's -1 over 3 times m to the power of, what's 4 minus 3? That's just 1, isn't it? And n to the power of what? Of 2. And this is all over 2. Right. Equals. Now all that's left is to multiply, right? We can't simplify any further. We have to multiply. And when you are multiplying, what do we do with my exponents? We add. See, multiplication is all that's left. We're going to add. So in m, I'm going to have m to the power of 5 plus 1, n to the power of -1 plus 2, divided by, what is 3 times 2? 6. So my final answer is m to the power of 6 n over 6. Nice, señale. How did you like everything we've done before we go to the brain break? Thumbs up, thumbs down on everything we've done so far. What do we think? I only have 4 thumbs up for about 30 people. There we go. That was a nice one. Wait till you see what I have in store for you, Achille. Okay. Let's go to our brain break. Is anyone talking to me today for the brain break? Oh, hello, Charlie.
Hi.
Charlie, tell me, would you rather always wear sweaty shirt or sweaty socks?
Shirt.
Shirt. It's gonna stick on you.
But my socks gonna smell like feet, which is more it's stronger than the shirt.
So you're scared of smelly feet. I love it. Oh my goodness. Okay. Thanks, Charlie. I understand your logic though, guys. Sweaty socks means your feet stink. I get it. I see a lot of people are voting socks though, so you guys are not afraid of, yeah. Guys, Pela, sweaty socks means your shoes also. Oof. Oh, you used to sweaty okay. Next one, would you rather be half your height or double your weight? Half of your height or double your weight? Half my it's like, yo, this is a lot. Guys, if I was half my height, could be mistaken for a toddler. That's how short I am. If I was half my height, I would literally look like a toddler. So I would rather double my weight because, guys, I can't be, come on, I would be so tiny. And not your weight, Mutebang, your height. Lomso says double because I'm thin. So actually, would you rather be half your height then? Charlie's like, it's fine, take the height. I'm tall anyway. Umpa's like, let me give you guys live tips. Bicarbonate. Umpa, I'm actually gonna take that tip. Mutebang is also going with half height. Guys, how tall are you guys? I'm actually so concerned that most of you are choosing half your height. Wow, I'm so surprised. I'm so short. Your name is Mbali. You must change your name then. You can change your own name. Let me change it for you. I would also be a dwarf lom, so that's what I'm saying. I would really look, never mind. Never mind. Never mind, Charlie. I just changed your name, but your name is not actually Mbali. There's a lot going on here. Would you rather have zombie hands grab you at night or for your pet to start saying things at night, like creepy things? What do you guys choose? Callie, let me change you back. That was funny. Now I don't know if I spelled your name right. Hey, there's a lot going on here, guys. Oh, a lot going on. Zombie hands. I'm fine with the talking, but it's not just talking, it's saying creepy stuff. It's not just saying hi. It'll be like imagine a deep voice and it just says like a riddle or something that is really creepy. I'd be like, excuse me? I would give it away. I'd be like, nope, bye. Mm-mm. And then imagine it never speaks again. Like it's that one time and then never again. Guys, you'd lose it. You'd go crazy for sure. And then the last one, guys, would you rather eat nothing but a salad or nothing but dessert for a whole week? Rawa, see, the dog thing is very crazy for me. I don't get it. Guys, nothing but desserts. So breakfast you eat milk tart, lunch you eat malva pudding, dinner you eat ice cream, tomorrow breakfast cake, lunch, how guys? Hi, 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 hi. Phew, I would lose it, guys. All that sweetness. No, I wouldn't be able. I don't have a sweet tooth. Maybe that's why. No, I think I just don't have a sweet tooth. Like I wouldn't be able to finish it. I wouldn't survive either as an Andy. Okay, guys, are you guys ready for nice questions that I found for us to do? Are we ready? Okay, that was me doing a little dance. It looked terrible, but it is what it is. Okay, I see people. Oh, okay. Stop it. Okay, so this was number 18. We are on number 19. Okay, we are on number 19. Yeah, I also used to mukbang. I don't know what happened. Now I can't stand sweet stuff. Like I could have a chocolate for 3 months straight until my family's like, I just give us the chocolate. It's been in here for a very long time. Okay, so inside the brackets, is there anything inside my brackets that I can do, that I can simplify here? No. So let's start with my exponents. What are we going to do with these guys over here? Okay, well, it's actually the one at the top, just the one at the top. Distribute, okay, equals. So it's going to end up being -4 squared, a squared, and b to the power of 4. All over -8, and this whole bracket will be what? This whole bracket will be 1. Okay, divided by AB over 2. Nice. Now what's -4 squared? The whole -4 squared. It is positive 16. Remember, -4 squared is -4 times -4. Two negatives give us a positive. So it is 16 a squared b 4. And then at the bottom, what's -8 times 1? It's -8. Okay, now let's fix this part over here. What can we do about this guy over here? What can we do about it? Tip and times. So I'm going to change this to a times. I'm going to put my 2 at the top and an AB at the bottom. So if you paid attention, you know that I just did 2 steps in one, which is allowed because I didn't change anything. Okay, now let's go back here. Can we still simplify over here? Can we still say, yes, we can. What's the common factor between 8 and 16? 8. It's actually -8. So -8 goes into itself once and into 16 -2 times. Okay, so then I'm left with -2a squared b to the power 4 times 2 over a b. Where do we go from here? Where do we go from here? Do you guys want to multiply first? No, you don't need an LCD. When do we need an LCD, guys? Let's remind each other. When we are When do we need an LCD, beautiful people? No one knows. No, when we are adding and subtracting fractions. Not when we are multiplying and dividing. Yes, minusing is the same thing as subtracting, but I get what you meant. I get what you meant. Okay. Now, thank you, Leachile, for your answer. If you missed that, I asked when it is necessary to find the LCD, and the answer was when we are adding and minusing. We're not adding and minusing in this case. Remember, guys, this is the same as all of this over 1. So how do we multiply? We multiply the numerator with the numerator and the denominator with the denominator. That's it, right? Now, in my numerator, I have a -2 times 2. What's -2 times 2? Let's make some space over here. It is -4 a squared b 4 over, what is 1 times ab? It's just ab. Okay, can we still simplify here? Yes, we can simplify the exponents. So that is equal. Negative 4, we are dividing. So what are we going to do with my exponents? Subtract. So it's going to be a to the power of 2 minus 1 and b to the power of 4 minus 1. So for my final answer, it is negative 4ab to the power of, it is a to the power of 1, but it's b to the power of 4 minus 1, which is 3. Nice, guys. Pretty interesting one. Okay. Let's move on to this guy over here. That was number 19. We are officially on number 20. This looks very familiar. No, we haven't done it. We haven't done it. Okay. Inside the bracket, is there anything that I can do? Yeah, we already did 20. Imagine. No, there isn't. So let's distribute my exponents, okay? So I'm going to have AB squared C over a to the power of what? We are now distributing this 2 over here. So it's going to be a to the power of 2, b to the power of 2, and c to the power of 4 times. Guys, haven't we done this? This feels very familiar to me. I'm pretty sure we have done it. People who are writing are taking screenshots. We haven't. Okay. Sorry, I'm losing it. I'm obviously losing it. My brain is losing it. Times. Yeah, maybe another class. Maybe another class. Let us distribute my negative 1. Okay, so it's going to be a to the power of positive 2, b to the power of, I need another brain break, negative 3, and c to the power of, nice, thanks, Senyani, negative 1, all over. A to the power of 0 is equal to what? 1 times b to the power of 4. Great. Where do we go now? Do we first want to divide or do we first want to multiply? First divide or first multiply? Divide. Okay, let's do this individual ones alone. So for this one, we are dividing. So what are we going to do with my exponents? Here's my division line. So we subtract my exponents. So it's going to be a to the power of 1 minus 2, b to the power of 2 minus 2, and c to the power of 1 minus 4 times. You're going to help me with this. Okay, this one, there isn't much to do. It's a squared, and it's b to the power of what minus what? Minus 3 times 4? Is b to the power of minus 3 minus what, guys? Minus 4. And then c to the power of negative 1. So I'm going to simplify this to make life easier. This is a to the power of negative 1, b to the power of 0, c to the power of negative 3, times a squared, and b to the power of what? Tequila, affile. B to the power of negative 3 minus 4. What's negative 3 minus 4? Nice, negative 7. And c to the power of negative 1. And now we are on our final step where we are multiplying. So what am I going to do with my exponents? I'm going to add them. So this is a to the power of -1 plus 2 times b to the power of 0 minus 7 times c to the power of -3 plus -1. Okay, I was wondering why there's a -7 there. It's because it's a plus -7, which is going to end up being -7, like so. So those plus minuses are going to end up making what? They're going to end up being negatives. Okay, now we can go to my final answer. What's -1 plus 2? It is 1. So it's just a 0 minus 7, b to the -7, and 3 minus -3, excuse me, minus 1, -4. And everyone who loves the negative exponents, we know we can simplify this answer to be a over b to the power of 7, c to the power of 4. That was a beautiful one. Even my brain malfunctioned for a second there. For more than a second, but it's fine. We've recovered, we're good. All right, I think we have time for more, so we're gonna do more. This guy. Okay, we're gonna do 2 more. This is gonna be the last one that we do. No, let's do this one, and then we're gonna do a cool down. Right? Because we need to cool down our brains. Number 21. Number 21. I'm gonna move this guy up. Guys, everything that's here is stuff that you've done, so do not freak out. 21. Nice. Are we too fast, Simtandile? You know you can tell me to slow down. If I'm too fast, please tell me. Do you want me to go back to the previous one? Oh, okay. All right. As long as you're fine. All right, guys, let's look inside the brackets. Is there anything I can do inside the brackets? No. If you look here, it's just XYZ squared. Over here as well, there's nothing really that we can do. There is actually something that we can do inside this bracket, isn't it? Can we not do something inside my second bracket? This guy over here. Yes, we can divide within the bracket before we distribute the exponents. So I'm going to rewrite everything else, which might take a while. XYZ squared -1 over x squared y -1z cubed divided by, whew, now we're inside my brackets. When you are dividing inside, we are dividing inside the bracket. So what are we going to do with my exponents? We're going to minus them. Okay. So in my brackets, I'm going to have x to the power of 3 minus 4. Okay, I don't have to do that. I think, what is x exponent going to be? We are subtracting, so then x is going to end up with a -1 exponent. Y is going to end up with a my exponent for y, a 0, and z is going to end up with, it is 0 minus -3. Think about it. 0 minus -3. It is a positive 3. Thank you, guys. -1. Think about it. What does a plus and a plus give us, Leachile? These guys. They give us a positive. So then you end up with 0 plus 3, which is 3. Do we understand? Hopefully we get it. Okay. You're welcome. Okay, we're back on track. We're back, aren't you? We're getting there. I was just doing one step at a time. So then it's x, y squared, z 4 over x negative 3, y squared, z 0. We have dealt with brackets. What's next? Motibang has said it in the chat. We're going to distribute this guy and that guy. Okay, so my numerator over here, my new exponent is what? If I am distributing this negative 1 inside, it's going to be x to the power of negative 1, y to the power of negative 1, and z to the power of negative 2. Right, at the bottom it's just the same. X squared, y to the power of negative 1, z cubed. Divided by, we're distributing a negative 1 again. So inside it's going to be x to the power of this time we're distributing this guy. 1, thank you. I'm not going to write it. Okay, this y to the 0 just becomes what in total? Y to the power of 0. It's a what? So I'm just going to get rid of it because it's 1 times x. So it's just x. And then we're going to have z to the power of 3 times negative 1. Negative 3. 3 times negative 1. Okay. Times. Is there distribution here? No. So I'm going to rewrite again. X squared z 4 over negative 3. Of course, I'm going to say negative 3 because I'm looking at the exponent. Over x to the power of negative 3. Y squared z 0. Whew. Okay, now what? Do we want to divide first? Or what kind? Yes, let's divide first. Okay, I'm going to start with this one. It's going to be, we're dividing. What am I doing with my exponents? Minus. Okay, so I'm going to have x to the power of negative 1 minus 2, y to the power of negative 1 minus negative 1, and z to the power of negative 2 minus 3, divided by, this one is just going to stay the same, times x to the power of 1 minus negative 3, y to the power of 2 minus 2, and z to the power of 4 minus 0. Whew. Ay, shame. Let me simplify quick. What's negative 1 minus 2? Negative 3. What is this minus going to create for us here? This guy. A plus. So it's going to be negative 1 plus 1. So it's going to be y to the power of negative 1 plus 1, guys. Negative 1 plus 1. Nice, Jason. It's a 0. And then z to the power of negative 2 minus 3. It's the negative 5. Divided by x, z, negative 3 times x is going to be to the power of 1 minus negative. What is this minus negative going to do for us? So it's going to be x to the power of, this is a plus 4. Thank you. Y to the power of 2 minus 2, which is 0, and z to the power of 4 minus 0, which is a 4. Whew, now we only have times and divide. Do you guys want to do one step or do you want to do one step at a time? Must we just do one long step or one step at a time? We only have 5 minutes left, guys. One step at a time. Okay, let's first divide. How's that? Let's first divide. So if I'm dividing, what am I going to do with my exponents? If I'm dividing, what am I going to do with my exponents? Minus them. So it's going to be x to the power of -3 minus 1. That comes from here, in case someone has been lost there. Okay? And then y to the power of 0 is just 1, so it's gone. And z to the power of -5 minus -3 times x to the power of 4. That y is also gone. And z to the power of 4, which is going to give me x to the power of what? What's -3 minus 1? -4. Z to the power of, this guy's going to be a plus -2 times x to the power of 4, z to the power of 4. Now we are in the final step where we are multiplying. When you multiply, what do you do with my exponents? We add, so it's going to be x to the power of -4 plus 4, and z to the power of -2 plus 4. What is -4 plus 4? 0. So this whole thing is going to be a 1 times z to the power of 2. So my final answer, guys, that whole expression was just a z squared. Whew, that was beautiful, don't you think? I told you guys I had nice things ahead.